Hi, I'm Tony,
I'm Abby.
and we're gonna be going more in depth into Git for collaboration because we have a lot of feedback on wanting a lot of more time and depth into this.
Yes, and we're also going to be reviewing some of the initial basic Git stuff, like how to make a commit.
Yeah, okay. So we're gonna be going over the basic stuff. So staging, committing, logging. We're gonna go into branching and creating new feature branches. And then we're gonna go into how to merge these branches together and actually how to collaborate remotely using Git. So first, we're gonna recap making commits. And so what a commit is like it's just an encapsulation of a bunch of differences in code changes. So for example, let's say this commit is about adding code to render one single comment in Capbook. Then maybe in the single comment.js file, I added and deleted some code. And in card.js, I added and deleted some code. All of these code changes bundled together make a commit with a little message. All right, right here, add a code to render one comment. Now, naturally, if we have a sequence of commits, we kind of have like a work history slash version history of our code. For example, maybe first we added code to render a comment, then we added code to render blocks of comments, and then we added code to style the comments. And what we're looking at, which is the most recent version right now, is called the head. Now, let's say that we wanted to add a new commit. What do we exactly we want to do? Well, let's say that the next step in our project is adding post functions, like posting comments functionality. So in order to add this commit, we first make a set of code changes. Maybe a code change can be in new post input.js. Another could be in API.js. Another could be in the profile page. And let's say I make another code change in the new post input.js. Now, let's say that we're actually thinking about making a commit. So we introduced the concept of a staging area where the syntax, get add, and the file path will take all of the changes, all of the code changes in that file, and put it into the staging area. So if I do get add new post input.js, then all the changes in new post input would be added into the staging area. I could also add multiple files into the staging area, such as get add api.js.
And you can
Now,
also add some, leave some out of the staging area
yeah,
so that you don't want to go into the commit, but stuff you've changed.
yeah. Let's say my commit wants to be about posting comments only. Then the profile page has nothing to do with it. So I'm able to just take a subset of the code changes I have and add it to the staging area. Now let's say that we want to solidify the commit. So we take all of our code changes in the staging area and do git commit dash m with a commit message, such as add post, as adding post comment functionality, and then it'll be right there on the top of our git log.
Yeah, you committed. Good for you.
So so to recap, I make a set of code changes. I use git add to add those files with code changes into the staging area, and then I formally make a commit using git commit. We can abstract the sequence of packaged code changes into something called an object graph, where each circle or node corresponds to a single commit, and an edge between the nodes represents the sequence at which it happened. Each one of these nodes would have something called a commit ID, which is a little hash or unique identifier of it, and also a message describing what that commit was about. So going on to branching, we don't actually need to remember everything that happened in this scenario. We just need to know that Tony needs to do task A, task B, and Abby is forcing Tony to do task C. And Tony's really stressed because he has to be able to work on multiple features at once. So let's say that Tony doesn't use something called branching and tries to use one commit log. Let's say that the blue is everything for task A, the green is everything for task B, and the yellow is everything for task C. And I start my commit log using maybe just bare bones for task A, bare bone code for task A. And then I start task B somewhere in the middle. I work on a little bit. And then Abby starts yelling at me, and I didn't finish task B yet. And I make a commit to task B. And as I'm working through the different parts of the code and different projects and different features, my commit branch gets really, really messy, more and more messy. And let's say that one day, Abby asked me, hey, there's actually a bug in task C, bug number 6 specifically. Where did this bug start? And Tony has this history of commits, and it goes like, I'll try to find it. Unfortunately for Tony, all of these actually look exactly the same in the commit log. There is no differentiation between the different tasks that we wanted to separate out. So I would have to look at every single one of these individually, and it's actually pretty impossible to find. I'm unable to separate where exactly this bug started. So this introduces the need for branching and merging, where we can create new branches for each different type of feature and organize our commits into these separate commit histories. And we are able to merge these commit histories together back into one single project. So I'm going to demonstrate an example of merging. On the left, we have my terminal. Right here, I have my Visual Studio Code. And here we have Abby drawing some object graph. Now I have already made one commit already,
Can you get log to show us that commit?
and I use git. I have to cd into the directory first, and then I can use git log to show the commit. So as you can see, in one commit, I have a start to task A. Now let's say that I wanted to just get started on task B. I would use the command git checkout -b to create a new branch. Now let's say I call this a task B branch. Now the head pointer actually changed. I am no longer looking at my main branch. I'm actually looking at this new branch that I'm on. I can tell also that on the bottom left of my VS Code, I can see that I'm on task B. Also, if I type git branch, it also shows that task B is highlighted in green.
And just to clarify, the head pointer is just wherever your working directory is currently representing. So that could be a specific commit, or it could be on a certain branch. So right now we're on task B branch. And so that means that any working directory, any changes and things that you see in the working directory are relating to task B.
So let's say I make a new task, new file called task B. And then I make some progress in task B. Now to save all of these changes, I would add and then I would commit. And I actually can do something called git add dot, where I could just add put every single file into the staging directory from my current folder. Because if you remember, the singular dot just means the folder that I am looking at right now. And if I do git status, I can see that in green, it means I see that task B has been added to my staging area. Now, if I do git commit, started task B, then I have officially made a commit in task B. I can also make more code changes, and I can just repeat the steps. I do git status and see that my change was unstaged. I do git add to put this file into the staging area. I do git commit progress in task B to make a formal commit in my commit history. Now, if I do git log, I see that I officially added these two commits, and I can look back on it in my history. Now, I could get checkout back to main to switch my branch back to the main branch.
So this is moving our head pointer to go back to main.
Yeah. As you can see, if I do git log once again, I can only see the start of task A. I cannot see any of the things I've done in task B, and my task B.txt actually disappeared. Now let's say that I want to take all the changes from task B and I want to merge it back into the branch that I'm currently on. How I would do that is to git merge task B. So I am currently on the branch. I'm checked out to the branch I'm currently on, and I do git merge and and the history that I want to merge from.
So we're on main, our head pointer's on main, and then, oh, I'll show you here. And then we're trying to merge from task B into main.
Yeah. So once I do git merge task B, I can see that all the changes in task B actually merge onto the main branch. If I do git log, I can see that the task B commits are actually merged into the main branch. Now, let's say that there are some cases that we're going to have some complications. Let's say that there are two different things that I'm trying to merge. Let's say in a certain file, branch A says that Abby is wearing a pointy hat, and branch B says Abby's wearing a bucket hat. And if I try to merge these branches together, Git will tell me that I'm trying to tell it two different things at the same time, and they'll be really confused because it'll be like, what type of hat is Abby actually wearing? Is Abby wearing a bucket hat, or is Abby wearing a pointy hat? So this is something called a merge conflict, and I will demonstrate it in a new repository. So let's say that I'm trying to demonstrate a merge conflict. So I have a bucket hats.js file that I'm going to have conflicting information on. So first, what I'm going to do is I'm going to create a new branch called bucket Abby.
Wait, can we log to see where we are?
Oh, so if I did get log, I see that there's only one single commit, which is just the start of the repository.
And this is on branch main.
And this is on the main branch. Now I could do get checkout -b bucket Abby to create a new branch called bucket Abby. And maybe on this branch, I tell the file Abby has a bucket hat. And as usual, I do get add to put this file in the staging area, and you do get commit -m and make a formal commit. Now, if I check my log, I see that my log set now says that Abby has a bucket hat. Now, if I check out to main, I see that it doesn't say that Abby has a bucket hat because we are in the main branch now. We don't have the edit that says that Abby has a bucket hat. So here we can say that Abby has a pointy hat. I did get add. I did get commit. Pointy hat Abby.
Right.
And in my log, I see that I don't have the bucket hat Abby commit. I only have the ones for the start of the repository and that Abby has a pointy hat. Now, what's going to happen is I'm going to try to merge the changes from bucket hat Abby into my main branch. And there will be there will be conflicting information between the two files. One will say that Abby has a pointy hat, and one will say that Abby has a bucket hat. So I do get merge bucket Abby to merge the changes from bucket Abby back to main. And we see that we have something called a merge conflict.
Oh no.
Oh no. So there is something called a current change, which is the change that is on my current branch. And that I also have an incoming change that changes from a branch that I'm merging from. Now I'm able to choose what change I want to take, or I can even add new information. So let's say that for here, I only want to take the change from the incoming branch. I see multiple options here, accept current change, accept incoming change, accept both. And because I want the Abby as a bucket hat option, I'm going to just say accept incoming change.
And we could even change that to be whatever we want. So if you wanted to say like Abby has a big bucket hat, then that could also be part of the merge conflict resolution. You can do whatever you want.
Yeah. So in making the merge commit, I'm going to get add, get commit -m, merge resolution. And if I do get log, I see that I have the changes, both changes merged into my main branch, and I also have a new merge commit for merging the two together. So that's how you resolve a merge conflict.
So now all four of these commits are going to be in our history.
Yeah. So now we can see we have a merged history that says that Abby is just wearing a bucket hat. Okay. Now what we can also do is we no longer need the original branch anymore. So we can actually delete the original branch that we have.
Can we go back? Want to do git branch?
Yeah, so if I do git branch right now, I can see that I have bucket hat Abby and I have the main branch.
Even though we merged bucket Abby into main, it didn't delete the branch. It's still there.
So we optionally we can clean up this branch. You get branch -d bucket Abby, and this will delete the branch that I was on for creating the bucket hat Abby commits. So if I do git branch again, it's no longer there.
And this is good practice. You don't need to delete your branches, but generally we like to make anytime we want to add a new feature, we make a new branch, then we code on that branch, then we merge it in, then we delete it.
All right. So moving on to remote Git.
Okay, so all of that, the branching, the committing, all those things were just a very fancy version control organization tool on your own machine. But the real power of Git comes in when we start collaborating with others. And so how do we collaborate with others if we have like an object graph and some files on, on our local machine? Well, the answer is we just take that and make a copy of it and put that copy on a remote server somewhere. So just some kind of computer on the internet that stores our project, which includes the object graph, and people can look at all of our files and things. So there's a lot of different services that do that, but the main one we use is GitHub. So let's say that I made a copy of my repository on GitHub, and then Tony wants to work on it too. He does git clone and then puts in the link that he got from GitHub. And then now he has a copy of my repository too. And let's say he wants to add things. So he makes a commit, he does some work, commits it, and now he has this commit on his local version of the repository, but I don't know about it, and the remote server doesn't know about it either. So to tell him about it, he has to do git push. And so what git push does is it just tells the remote server about all the new changes that he made and makes the remote server look like what he has locally. Now let's say that I want to start working on stuff, and I do git pull to take whatever he has and pull it into my local repository. So git pull just makes my local repository look like the remote repository. So the basic workflow with remote is we want to pull as soon as we start working and very often in case someone else has made changes, because we want to always be building off of the most recent version of the code. Because then if we don't, then things get messy. So always pull and then do whatever work we want to do, add things, commit things. And then we can push our changes. So pull commit pushes the basic workflow. But if you push and people have made changes since you last pulled, then Git will yell at you and you have to pull. So that's why we have pull, work on stuff, then pull again, then push. All right, so now things get a little bit more complicated when we're working with remote and we have branches involved. So let's say, okay, let's say we make a new branch. Tony wants to work on WebLab Tinder, and he makes a local branch called WebLab Tinder. And then he makes a commit on it. Very cool. Now he wants to push that to remote so that there's a remote branch that also has this information. So he does git push.
Oh no, I got cock blocked by GitHub.
Oh no. It says the current branch has no upstream branch. What does upstream mean? So to figure that out, we have to look at what's going on under the hood a little bit more. When Tony cloned this repository initially, it created this link. The red thing represents this link between local main and remote main. And that link is known as tracking. So you can say that your local main tracks remote main. It's also known as upstream. So you can say that the upstream branch for your local main is remote main. And when you clone this, Git automatically sets up this red link, this little link for you between your main branch and the main branch on remote, because it knows that your main branch should correspond to the main branch on remote. However, since Tony created a new local branch, WebLab Tinder, Git doesn't know if there's a branch on remote that it's supposed to correspond to. Actually, there isn't. And so what we do is we do git push, set upstream, origin, and then the name of our branch. So what that does, if you can go to the next slide, is if Tony says git push, set upstream, origin, Tinder, then that creates a new remote branch called Tinder. So origin just refers to remote. And then it sets the upstream branch for his local WebLab Tinder branch to be the remote Tinder branch. So it sets up that tracking between, so it creates a new remote branch and then sets up that tracking between the new remote branch and the branch that he's currently working on. All right, so let's say Tony wants to keep working on WebLab Tinder. So he adds some things, he makes some code changes, and then he commits some things. Next slide. And he's made some commits, and now he wants to push those changes to remote. Now, since there's already that red connection between his local WebLab Tinder branch and the remote Tinder branch, he can just do a regular git push. and then it'll automatically update the Tinder branch. Because now Git knows that if I do git push on my local web lab Tinder branch, then the remote branch that I want to update is Tinder. So now let's say he's done with working on web lab Tinder, and now he wants to merge it into main. How do we do that? Okay. So Tony goes back to the main branch, and then he does git merge WebLab Tinder. So that is trying to pull the changes, pull WebLab Tinder and merge it into main. And so he does it, he resolves any merge conflicts he comes across. It's all merged together. Great. Bet. Then he does git push to try and push that merge commit, so push that merge to remote and do the same thing on remote as he did on local.
Oh no, Tony got cockblocked again.
That's crazy.
That's so crazy.
Says updates were rejected because the remote contains work that you do not have locally.
What happened?
Interesting. So let's see what happened. Tony's confused. And then he does git fetch, which is like git pull, but instead of, so what git pull does is it fetches, so it downloads any changes from remote, and then it merges those changes from remote into his working directory, into his working copy. But git fetch doesn't actually try and merge anything, so you won't encounter merge conflicts or anything, but it just like downloads to see if there is work on remote that you don't have in your local yet. So he does git fetch. He looks around. And he discovers that there's a new commit on main that I made in between when he last like branched off for Robot Tinder. And so now Git is confused because this remote graph does not, or like the bottom half of his graph, everything except the merge commit, doesn't look the same as this. So Git's like, oh, these two things are incompatible. How do you push this? And it's very confused. So what Tony has to do now is he has to do git pull. So he checks out to his main branch, his local main branch, and then he does git pull, and then that pulls whatever was in the new commit from remote main into his local main. And then when he does git pull, then he has to, like, he might encounter merge conflicts or anything. He resolves those. And now it's safe to do git push, and he pushes his merge commit to remote main. And he could do that because the bottom half of his graph looked the same as the bottom half or as the graph on the remote server. And then, of course, he has to delete his branch, his local branch, WebLab Tinder, because just for cleanliness' sake. All right, so this slide is mostly for reference for you guys if you're working later and you want to remember some of the things that we just talked about. So I won't talk through this. Okay, now the workflow that we just did was we merged and then, wait, can you go to the next slide? All right, so the workflow that we just did was we made a local branch, we made a remote branch. We, coded on and made commits on that local branch and pushed them to remote, etc. And then on local, we merged our branch into main, and then we pushed that commit to remote main. So we merged it and pushed the merge commit to remote main, and that's how we got it merged in remote. However, that involves pushing to remote main, and in a company, you're actually typically not allowed to do that because in a company, remote main is what all of the developers are using to test and to develop and to do all sorts of things. So if you break something in remote main, that is a big L for everyone.
Yeah, maybe if you worked at Microsoft, you would push directly to main. If you were able to, you might have just broken email for everyone who uses it in the US. So yeah. Usually in industry, the main branch is protected. And in order to actually merge the changes, we need to create something called a pull request. Essentially what this is, well, first we have to make sure that we have all of the changes from the main branch and pull it into our local working branch, just so that our working branch can be up to date and there won't be merge conflicts later on.
Because if we made a pull request with just on main here, then we would say, okay, I have these commits on the Tinder branch. I want to try and merge Tinder into main. And then there might be merge conflicts that arise because the commit on main, or like the version of main that we based our Tinder branch off of, is different than the most recent version of main that we're trying to merge Tinder into. So that would be sad. So we want to make sure that our branch includes the most recent, all the most recent changes to main.
Yeah. So now that hopefully future merge conflicts are resolved, we can push that into onto our feature branch on the remote branch.
Yeah. So just to reiterate, we were on our local web lab Tinder branch. Notice that the head pointer is here, and we did git pull origin main. So we pulled any new changes from remote main into our local branch. And then we push the changes that we pulled onto our remote branch.
Yeah, so this is a method to update the remote branch of our new feature. Now we are ready to merge these together, which is creating a pull request. This involves exiting out of the terminal and going to github.com and clicking the button called create a pull request. So this is not on the terminal. Then you typically need some manager approval. Let's say Abby here is my boss, and she looks at the pull request and she goes like, this is actually okay. So she actually goes onto github.com and clicks on the complete pull request button. So now the main branch on the remote server is going to be updated. And also, I can also fetch this newly made remote main by checking out into our personal local main branch and doing git pull, taking all the changes on remote main and pulling it onto my own computer.
Because the pull request being completed, that merge happening was something that all happened in GitHub on the remote server. And so in order for Tony's local copy to reflect that, he has to do git pull.
So once we are done with that, we no longer need that new feature branch. So good practice is locally doing git branch -d web app center to basically yeet that branch because we don't actually need it anymore. And on github.com, also manually deleting and pressing the delete button on it.
You can also have it automatically delete when you make your pull request.
Yeah, there's a little checkbox that says delete my feature branch after after pulling it in. Yeah. So workflow in industry, this is for you guys to be able to have for reference. We won't actually go into the step by step since we just went through it in the diagrams. It's the same exact thing that we just talked about.
Okay, so just to recap, we talked about committing and merging on just like in a local environment, and then we added remote and talked about two different ways that you can make a branch for a new feature, develop your new feature, and then merge it back in. The first one that you'll probably be using in your web lab teams, that's just merging and then pushing your merge commit. And then the one that you'll use in industry, which is updating your feature branch on remote and then creating a pull request. So now we're going to talk about another little useful side topic, git stash. Okay, so let's say that Tony is working and he's made some changes to some files, but he hasn't solidified it into a commit yet. He's still working on it. But then he wants to check out to a different branch. Like maybe he wanted to go back and see what main looked like and yeah, to like reference the version of code that's in main to base his code off of it or something like that. So he does git checkout main.
Oh no, he got cock blocked again.
Upside down this time.
Upside down this time. Crazy. What happened?
Error. Your local changes to the following files will be overwritten by checkout. Says, please commit your changes or stash them before you switch branches. Okay. Well, Tony isn't ready to commit those changes yet. But the problem is, in order for him to check out to main, checking out to a different branch moves the head pointer. That means that it changes where the like part of the commit history tree that his working directory reflects. So what moving the head pointers and checking out to main would do is it would overwrite all of the files in his folder to reflect what's going on in main. That's how he can like look at what's going on in main. However, that would be sad because if it overwrites the files, then it would just yeet all of those changes that he just made.
That would be so sad. So we have something called git stash, which basically takes all uncommitted changes and basically puts them away in a little box. So now that all our changes are stashed in a little box and are safe in our little box, we're able to move the head pointer however we want. We're able to check out the other branches. Let's say check out to some other feature branch, check out to our main branch, and our changes are still safe in our little box. Something we could also do is pull in other changes from other branches. So for example, here we're also able to say something like get pull origin main and take the changes from the remote branch and put them right on top of our feature branch. So all our uncommitted changes can be popped right on top of everything that we pulled in so far using get stash pop, taking all the log uncommitted changes in the box and putting them right back onto the top of the Git log.
So to summarize, Git stash, there's a lot of different things you can do in Git that will overwrite the files in your working directory. You could pull changes in from remote. You could like merge one branch into another. You could check out from one branch to another. Lots of different things. And if you have changes that you're working on, but you're not ready to commit yet, but you want to save, then Git stash is a great tool for that. And so you just Git stash, do whatever you need to, and then Git stash pump.
Yeah. So working with Git stash, you just as you're working, you just type Git stash. Then you can do basically anything you want. Check out the other branches, pull, merge around, and then right when you feel safe in your commit history, you can do the Git stash pop, and all your local changes that are unsaved, uncommitted, will come right back on top. So just to recap some terminology we have, staging means getting a group of files to get ready for a commit. Git commit is solidifying all of the changes in your staging area and putting it in the Git log. Branch is to make the commit history diverge, often to group commits together for developing different features. Remote origin is the version of your repository that is elsewhere on the internet so that everyone can interact with it, not just yourself. And upstream is the corresponding remote branch to the local branch that you're working on. So it's the link between the two.
And you can also say that you have a remote branch that tracks your local branch or vice versa.
Yeah. General workflows, you basically, well, in WebLab, what you would do is, let's say you wanted to add a new feature, you create a new local branch, you set the upstream, and now you're able to create commits and pull and push often as much as you can to make sure that your code in your feature branch is updated with whatever's in the main branch on the remote server. And also you won't lose your changes since everything will be stored on GitHub after git push. After you're ready, either merge into main directly and push, or maybe if you're in industry or in a more professional environment, create a pull request so that it can get merged into main and approved by your manager. Oh, so that should that should be
Yeah.
everything for our Git for collaboration and everything you need to start working collaboratively on your code. All of these slides are for reference on weblab.is/slides. So good luck, guys.
Yeah, all of these things will be much more solidified when you actually use them, but we just wanted to have these slides and this recording up so that when you encounter certain situations like some of those errors that we showed on top of the cockblock images, then you will know why they happen and you can know what the corresponding object graph is. Also, our amazing staff member Enrique suggested a really cool resource in order for you to practice some of these concepts, so I think we'll put the link to that in the video description and on weblab.is/home.
Yeah, good luck, guys. Good luck on your project.
Yeah.
Bye.